All right. Hope you had a good weekend. I did grade your test. They are in Synergy. You can take a look at them. If you missed a half point or point, drop down percentage a little bit. Just be waiting. I'm going to be posting a video once everybody takes the test, and I have everybody submitted by the deadline, the end of this week. So once all the tests are graded and I've got everybody's answers in, I'll post a video, and that way you can look through and see which ones you missed and check them, and that way you have them going forward and see how you missed them. A few just little mistakes I think here and there. Everybody did really well, so that's good news. We're going to be moving into the new section now, and I'm going to write a word up on the board here and talk about this for just a second. Oops. Okay, variables. Variables in math are a very, very important term. It's going to be used through the rest of your math career. If you have a career in math that you want to do that, and you're like, I love math, I want to keep going. Even if you just take the rest of the classes here at the school, geometry, algebra, you're going to be using variables a lot. This is letters, basically, in math. When I run into people in the street and just happen to strike up a conversation about math, which doesn't happen that often, but if people start finding out I'm a math teacher, the first thing I usually hear is, oh, I didn't mind math until letters were put in there. And so it's not something that people enjoy. It's like fractions. Usually people just go, oh, why do they have to do that? But there is a reason. And hopefully I can break down a little bit of why we use letters in math. But basically, let's say I had a problem that we've known since, grade school maybe, of how to do 10 plus 2. When we do a problem like that, we've learned how to do this problem. Even if we have to go over to the side and line it up and add, we know we're looking for the answer as far as what it's equal to. And the unknown is over here to where we're solving just problems that we think we're just doing math problems, like 7 plus 8, 6 minus 2. And so we just think that we're doing a math problem and our answer's going over here, and it is, but the unknown is always what it's equal to. Well, what starts happening is, in math, as you go on, in algebra and geometry and even in here, the unknown starts being maybe here, okay? And they put an unknown here. And so instead of it being the answer that's unknown, now it's one of the, in this case, one of the additives that we're trying to find. And so we're looking and saying, okay, now the unknown's in a different spot, but it's still unknown. Instead of having it over here and not knowing the answer yet, now we know the answer, we just need to fill in what goes in here. Now, a problem like this, we could probably look at it long enough and figure out and say, well, it's 7. If I put a 7 in there, that's going to make this work out. It's going to make it true. There's no other number I could put in there, like a 3 or 12 or negative 15. Nothing else is going to make that 17, but a 7 would. Well, because this unknown is right here, we've got to put like a blank or a space or something there to show this is what I'm trying to figure out. And, at first people think, well, why not just use a question mark? But a question mark is limited, okay? For one, is let's say I have a problem a little bit further that there's 2 unknowns, okay? And so let's say I know that 10 plus an unknown minus something else is going to give me 12 or something. Well, now this question mark looks like this question mark, and I can't determine which one's which. This could be a combination of things. This could be like 10 plus 8 is 18 minus 6, and put an 8 and 6 there. But then later it could be 10 plus 9 and a 7. I mean, it's unknown. And if you have more than one, you can't decipher which one's which. You can't move them around. You can't combine them because they all look the same. Okay, and there's no way to decipher which one's which. So we can't just use a single question mark. We've got to use multiple things to decipher which one's which. So keeping on that same theme though, some people say, well, why not just use symbols? A question mark for one, a period for another, maybe an exclamation point. Well, the problem with that is a period is going to look like what? It's going to look like a decimal. Or even if it's up a little bit higher, it's going to look like a multiplication. So we can't use a period. Also, you may say, well, what about an exclamation point? In math later, you're going to find out that this is symbols already used in math. It means, like, if it's 10 exclamation, it means it's 10 times 9 all the way down. It's called a factoring, that you can factor all the way down. Okay? So, and we're not learning that, but just so you know, that does mean something. It means this number here. Okay? Now, and we're also, you know, if I use the pound sign, that's going to look like the number, like what we use for number. So really on symbols, we're also limited as well. Comma is going to make it look like 10,000 something, you know. So we're limited with symbols as well in math because we already use a lot of the symbols. So there is something that we can use that we have 26 of in the English language that could give us options and yet keep them separate, and that's letters. If I put 10 plus x, okay, now I know that here's my unknown, and I'm trying to solve, and I can solve for x later. On that one I was showing before, I could use x and y and go from there and realize, okay, x is going to be something, y is going to be something, and I'm going to be able to tell which one's which because an x is different than a y. So that's why we use letters. It's just to represent an unknown thing. Now later we're going to learn the rules to that, how to combine those letters, how to move them around, and that's where it gets, you know, tricky and challenging and kind of where students struggle to learn the rules and go through that. But, you know, usually, you know, as you get a grasp for what you're doing and why you're doing it, I think it really helps with working with letters in math. So basically it's just to put something in that space to show we're trying to solve what this is right here. And in this case, x would be 7. I'll give you an example now. We're not going to be this far yet, but I'll give you an example of how you could use. Now that one you could have solved without putting an x there. I think most of us could have looked at that and figured out that a 7 goes there. But you're going to learn how to use letters later that you'll see that this could be a good example of how to use algebra, and you may even use it without knowing you're using it. So let's say I said I had a class of 18 students, okay, so 18 total students, and I knew I had twice as many boys as girls. And let's say that's all I knew, okay? Now, once again, kind of a silly example, and you're not going to have to know how to do all this yet. This is as we get further on how to do this. I just want to show you how you can use letters to solve a problem like this. Okay, so all I know is I have 18 total students, so maybe my 18 could be over here. I have 18, I already have the answer, but now I need to know how to combine the others. Now, if I say I have some boys and girls, and to add them is to say and, so boys and girls, and I'm trying to figure out, now I'm going to use lowercase actually, because as you get into geometry, you'll see why we do that. But so I've got boys and girls, and all I know is I have twice as many boys as I do girls. So however many boys I have twice as many girls, but I can't put necessarily this and solve for this way because I can't combine a B and a G, and it still doesn't tell me how many boys and how many girls I have. But it does give me an example of where I would use letters to say boys and girls, and that way when I'm done with my problem, and I try to make it as simple as possible when I use letters. I use a B and G so I know, hey, that's going to be boys and girls. I don't necessarily use X and Y. I could use X and Y and then just try to remember that X was my boys and Y was my girls, but in this case I could use B and G, and that way when I'm done I know this stands for boys and this stands for girls. So it shows you can use letters even practically. And let's say I can't necessarily put 2G there, and you're going to learn that later on that you can't combine those. But basically I could look at it like this. So however many boys I have, okay, I have twice as many girls. So let's say I had 50 boys, then if I had, all right, twice as many boys as girls. So if I have 50 boys, then 2 times 25, if it comes out that the girls is 25, then that's going to be the same thing. So now what I can do is say, okay, if B is equal to 2G, and you're going to learn this later, how to do things like this, but just so you see why I'm using letters, now I can say, okay, if these are the same thing, that 2 times the amount of girls gives me the amount of boys, I can take this and put it here. Instead of using B, I can use 2G, and now my problem becomes like that. And now you're going to learn later on that I can combine those, and so 3G gives me 18. Then you'll learn how we can solve that. I divide both sides by 3, and I find out that I have 6 girls. Okay. Or, sorry. Yes. So, 6 girls is how many I have. So I solve for girls. And then B was 2 times 6 girls. So B would end up being 12. And so that's how I could solve for saying that I have 18 students and I have twice as many boys as I have girls. That's how that would break down. Now, I know that was a lot, and that was like, well, where do you go with those letters? How do you get those? You're going to learn how to do things like that much, much later. But at the same time, you're seeing that I could do a problem, and even a problem like that, if you stared at it long enough, you could maybe get it without doing this. But as you get bigger and harder, and as it gets easier to just substitute letters, you're going to see that it's much easier to use the letters and solve for things like that. Okay? Now, first thing I want us to do with letters is talk about verbal expressions and algebraic expressions. So verbal and then algebraic. Now, verbal means words. When we verbalize things, we use words to talk about something. So this is going to be things that we write out, and algebraic means numbers. We're going to use numbers. So like a thing like this is all numbers and symbols. 8 plus 2 equals 10. There's not a word in there. It's a number, symbol, number, symbol, number. Okay? But if I was going to verbalize that and say to, like, let's say a kid came in and I said, hey, this means 8 plus 2, and then a small child, you'd have to teach what plus means, but you could use words, 8 and 2, or the sum of 8 and 2. And over here I could say equals, or I could say is. 8 plus 2 is 10. So you're going to see that there's ways to verbalize these, and that it's not always just one way. So how I could verbally say this is, and I'm actually still going to use numbers instead of spelling out 8, but 8 plus 2 equals 10. Okay? Or I could have said the sum of 8 and 2 is 10. Okay, so that's verbal ways to say an algebraic expression. Okay, so this is how I would verbally say it to speak the words to what's happening here. Well, we're going to have to do that with variables, and because we have to kind of get a grasp of what we're doing to the variable, so that when we go to the next step and start working these problems, we know what we need to do to solve for them. So let me put this verbal expression up. A number plus 15 equals 20. Okay, a number plus 15 equals 20. Now what I want to point out is, what is my unknown? Well, it's this random number. Okay, I don't know what this number is. Maybe you've already solved it. I didn't make them hard, so we could look and say, oh, it's going to be 5, but as they get harder, you can't do that in your head. And so when you look at this, the unknown is this number. Well, that's where I'm going to use my variable. Okay, and you can use any letter. Your letter could be different than mine. I may want to use N for number, or just X. X and Y are used a lot. Let me use Y in this case. Okay, Y. So a number plus 15, so I'm going to show plus 15 equals 20. Okay, that's taking this verbal expression and putting it in algebraic. Let's do another one. 15 divided by a number is 5. So my unknown is here now. 15 divided by a number is 5. Well, now you could write that as 15 divided by x equals 5. And you see is the same as equals. What you're going to learn as you go on, most of the time when they're showing division, they're going to show a fraction. So just shorten it, abbreviate it, make it concise. So this is saying the same thing. 15 divided by a number, that's my unknown, that's my x, equals 5. Okay? Let's do another one. 3 times a number minus 12 equals 8. Or equals, actually I think I have it as equals 18. Okay, so 3 times a number minus 12 equals 18. Well, my unknown's here. Let's use z in this case. 3 times a number, so 3 times z. And when you times things, you can put them together. Remember when I did just 3 times 7 even? We could put them together. Okay, so that's what I did here. 3z, 3 times a number minus 12 equals 18. Okay. One more, and to show, I want to do this one because so far these kind of went in order. So a number plus 15. 15 divided by 15 divided by. And then 3 times a number, 3 times, I did them in order. But what about this one? 5 less than 2 times a number is 15. Well, this one I can't go, if I go 5 less and go 5 less 2 times the number, 2, let's use g, that's not 5 less than 2g, that's 2g less than 5. It's like taking this away from 5. So I've got to change places and say 2 times a number and 5 less than that. So I'm going to take 5 away from 2 times the number. So not all of these go in just perfect order. You got to read through and kind of figure out. So 2 times the number, 5 less than that is 15. Best thing to do, because that can get confusing when they start kind of changing the order, is when you get done, make sure what you wrote, if you were speaking it out to someone, it would say this. So if you were saying, if you were wanting to line this up and said, okay, I took 5 less than 2 times this unknown number, that is equal to 15. If you can speak that and it lines up with this, then you've put the correct algebraic expression to the verbal. Okay, so we'll stop there. I'm going to have you do a couple on your own for an assignment here. So I'll write the verbal, and you're going to write the algebraic. Okay, I put about 3 of them here. And I'm going to have you do this for your assignment to upload your photo. So 13 minus a number equals 5. Okay. And I spelled that one out. Then 10 less than 5 times a number is 20. And then the last one is 6 divided by a number is 3. And remember, whenever you're putting your variable, your letter, you can choose any letter you want. Okay, make them lowercase. Okay, and you're going to much later learn why that is, but keep them lowercase. And then you can put that, and so you'll put your algebraic expressions of these for your photo, for your upload. Okay, thanks guys.